Well, hello. Today we're going to be finishing up our time with probabilities, and specifically we're going to look at some probabilities involving some combinations. Okay, so let's just get right to it. Um, what's the probability of selecting two picture cards? A lot of what we're working on today is we're going to look at decks of cards, so hopefully you're familiar with that. If you've been following these other videos, you definitely should be by now. What's the probability of selecting two picture cards, either jacks, queens, or kings, when selecting without replacement? And that's important, right? Okay, so we know that there's four jacks, four queens, and four kings because we have our hearts, our diamonds, our spades, and our clubs. So that means that there are 12 face cards to choose from out of 52. And then something else we could do is we say, well, once we pick one of those face cards, because we're doing this without replacement, is once you pull that, King of Hearts and you set it aside, then you only have 11 hearts left. And then you only have 51 cards left. So then when you go through and you multiply this out, we end up getting this, and then that will reduce down to 11 over 221. So the likelihood isn't all that great that if you're just picking two cards that you get two picture cards. But we can actually do this another way, and this is a relatively easy way, but some of these probabilities get to be much, much trickier unless you start using combinations. So let's use this one that I know is pretty easy to do like this. But let's do it using combinations and just kind of reasoning through what we're doing. So if we think about drawing out a pair of cards, right, because we're going to select two cards. So think of those as a group of two cards. The order doesn't matter. It doesn't matter if you select the King of Hearts and then the Queen of Spades, or if you select the Queen of Spades first, then the King of Hearts. The order doesn't matter, which means that we're talking about a combination. And we have 12 face cards to choose from, and we're going to choose two of them. Then, as far as the total possible ways you could do this, there are 52 total cards, and we're going to be choosing two. So this is what we want. This is the total possible, right? This represents the total possible number of two card hands. Okay, so let's go ahead and I'm going to use this calculator here, and we can use 12C2, and this goes back to previous. Don't forget, it's just inside of option. Well, we got to be in the first one. So we go into option, we arrow over, we get to probability, and then this is where we can do our 12C2 divided by 52C, whoops, 52C2. And you can see we get that. I'm going to go ahead and hit FD. You can see we get that same thing, 11 over 221. So we do get the same amount here as what we did the other way. And I know some of you are like, well, man, I understand this. This makes sense to me. I just want to keep doing it that way. These get to be a lot harder. Work with this a little bit. Make sure you can understand why this makes sense. Right? We're taking out two cards, and it just says what's the probability of selecting two picture cards. It doesn't say give me any kind of an order. So we're talking about a group of two cards from our 12, and then two out of the 52 when we talk about the total possible ways of doing things. Okay. All right. Let's see about this here. Um, well, that's a little better. So let's say you have 8 bills in your wallet. You have 4 fives, 2 tens, a 20, and a 50. You definitely have more money than me, but I'd be happy if I had that in my wallet. If you just reach in and you pick out 2 bills at random, what's the probability that you selected 2 $5 bills? Okay. Well, let's think about this. We have 8 total bills in our wallet, and we're going to pick out 2 of them. The order doesn't matter, so 8C2. That represents the total possible ways you could select 2 of them. Any two. Now, we want the probability of selecting two $5 bills. So when I look up at this, I can see I have four fives in my billfold, in my wallet. So I have four of those. Then I can say I have a total of four and I want to choose two of them. So this represents the number of ways that you can choose two $5 bills. Because remember, we have four of them. So we have four fives and we're going to choose two of them. And we have eight total bills and we're going to choose two of them. Okay, so let's use the TI calculator this time in case we have some people out there doing that. So we've got 4C2, so I'm going to put in my 4, and then I'll arrow over, go into math, go over to probability, and then down to NCR, hit enter, and then 2. So 4C2. Of course, you could do this by hand, and these are pretty small. Like I know the other one's going to be 28, but that's just because I've done these a lot. Okay, maybe we will do this one by hand. 8C2 is 8 factorial over 8 minus 2, which is 6 factorial, 2 factorial. That's 8 times 7 times 6 factorial over, remember the order doesn't matter, like I can put the 2 in front. Those cancel. That's 4. And I get 4 times 7 is 28. I hope that's what I said earlier. Then we can reduce this down to just 3/14. So the likelihood of you reaching in and pulling out just randomly two $5 bills is 3/14. Right? And that's about a little over 20%, right? 21% roughly. Okay. So again, the total number of ways you could select two $5 bills, the total ways of selecting any two bills. That's the number that goes on bottom. A club consists of 4 men and 5 women. We're going to pick 3 members to form a committee. What's the probability that the committee is going to consist of 3 women? Okay, so we're going to pick them at random. It's like throwing all the names in a hat, and we draw out, and we end up with 3 women. Okay, so let's take a look at this. The first thing that we're going to notice is that we have 5 women to choose from, and we are going to choose a group of 3 of them. There's 5 women's names in the hats, and we're going to select a group of 3 of them. Now, how many people are there who have a name in the hat? Right, well, we got 4 men and 5 women. There must be 9 people in the bag, and we're going to select a group of 3. So we have 9C3. Okay, so can do this either by hand or on a calculator. It just depends on what you're permitted to do. 9C3 says 84. There are 84 possible ways of having a committee of 3 people in whatever club this is. 5C3 comes out to be 10, and then we can reduce this down to be 5/42, I hope. And you can verify that on your calculator if you'd like. But the chances aren't all that good of just randomly getting a group of 3 women, about 11% chance. Okay, if you're doing this just random. Okay, so the total ways of selecting 3 women, right? A committee of 3 women, and this is the total number of ways of selecting 3 people. All right, let's go on. A committee of 4 is to be randomly selected from a group of 7 teachers and 8 students. Determine the probability that the committee will consist of all 4 students. Okay, so maybe this is a good idea to pause and try to do this one on your own. See what you can come up with, because I'm going to do it right now. So the probability that will consist of all 4 students, when I look at this, I see that there are 8 students. And if we end up wanting 4 of them, I would say 8C4. This would be the total number of ways of having a committee that has 4 students on it. Now I'm going to say, how many possible 4-person committees are there? Well, there's 7 teachers and 8 students. That means there's 15 people, and we want a committee of 4 of them. Okay. This time, rather than do this one by hand, I'm going to actually just go to the calculator, and we'll just do it all on here. 8c4 divided by 15c4. There we go. I'm going to hit the little FD button to change it into a fraction. I get a nice little fraction of 2/39ths. And you can see that's just over 5%. So 2/39ths is our probability of having a committee of all 4 students. Now, this one's maybe a little more realistic. What's the probability of getting 2 students and 2 teachers? So this time it's going to be like a compound probability. We first want to look at the students. We had 8 students to choose from, and we're going to choose 2 of them. And we have 7 teachers to choose from, and we want to choose 2 of them, divided by 15c4. Right? Because we still want to choose a committee of 4. We're still looking for a total. And you can even see it here that we would say, like, look, here's 2 students and here's 2 teachers. That's our total of 4 people on the committee. Right? That's our total of 4 people. So when we go through and do this one, we've got 8c2 times 7c2 divided by 15c4. And I'll go ahead and change this over. 28/65ths, or about 43%. Okay. Oops. And that should kind of make sense because that's the most likely, like, that you would probably expect to get, because you have about the same number of students as what you do teachers, so you would kind of expect to get the same number of students and teachers on a committee like this. Okay. Okay. All right. This is the last one of these. Connor has a rare coin collection. It's made up of 8 silver dollars, 7 quarters, 5 dimes. He's going to end up selling 8 of his 20 coins. He's just going to reach in and he wants to sell 8. If he's just going to pick the coins at random, he's like, I have too many. I'm going to get rid of some. What's the probability that he picks 3 silver dollars, 2 quarters, and 3 dimes? Well, here's the deal. We know that the bottom is going to be 20c8. He has 20 coins and he's going to pick 8 of them to sell. Now we're going to go through and kind of break those up though. He has 8 silver dollars. We want to know the probability that he end up choosing 3 silver dollars. So that will be 8c3. That's the total number of ways that he could choose 3 silver dollars. Okay. Next, we're going to say he's got 7 quarters, and we want to choose 2 of those quarters. So we'll do 7c2. The last one says he has 5 dimes, and we want to know what's the likelihood that he picks 3 of them. So we have 5c3. Okay? And that's it. That's all there is to it. Like, this is can be kind of a complicated problem to do unless you're using combinations. This is pretty easy once you get the hang of it to just line them all up, and then you can do those by hand. The numbers come out kind of large. These are all relatively small. Like this one's 21, this one's 10. I don't, but it's pretty easy to put into the calculator, right? We're going to do 8c3 times 7c2 times 5c3. Looks like my times didn't go. Back it up there. Oh, that must have hit the wrong button. There we go. 8c3, 7c2, 5c3. That's our whole top. We're going to do divided by, and I'm going to do 20c8. All right. Not very likely. Let's go ahead and get that switched over. There we have a nice little fraction. And you can see it's not a very good chance, right? It's only it's about a 9% chance that that's what's going to happen. So, it's not a terrible chance, but not great. Okay, and that's all there is to it. Now we're going to go ahead and look at just a couple other probabilities in dealing with cards, just because they're fun, and this is where some of these come from. Now you can Google these probabilities, but we're going to actually look and see how you find these probabilities. So the probability of a flush, well, let's first start out with the probability of getting just a heart flush. A flush means all of the same suit, and we're talking about a 5-card hand. So someone deals you 5 cards and you end up with 5 hearts of any kind. Maybe, maybe you get a 2, 3, 7, a queen, and an ace of hearts. I don't know, whatever it is. But we want to know what's the probability of getting all of the same kind, and that kind being hearts. Okay? That's what we want to look at today, or at least with these last 2 or 3 minutes that we're going to be looking at this. So let's think about the total number of 5-card hands. Well, we know that we have 52 cards in a deck, and so that makes sense. That's going to be our first one. And if we're talking about a 5-card hand, the order doesn't matter, so it's a combination. 52C5. This is the total number of 5-card hands that you could have in any order. Now, if we want specifically to only have hearts, there are 13 hearts in a deck, and we want to choose 5 of them. So 13C5 divided by 52C5. That's going to be the likelihood of being dealt a heart flush. 13C5 divided by 52C5. Now, as you can see, this is scientific notation. There it is written out in a reduced format. But this scientific notation means that you'd move this decimal 4 places to the left, so 0.000495. About. That's the probability of getting just a heart flush. Okay. Now, the thing is, though, that oftentimes when you're playing cards, it doesn't matter if you get a heart flush or a club flush or a spade flush or whatever. And so we can find the probability of getting any flush pretty simply. Well, let's start out with that idea of 13C5, like if we want just hearts. Then the only thing that we actually have to do is to say, you know what, we could do this with hearts, we could do it with clubs, we could do it with spades, we could do it with diamonds. That's 4 of them. So it seems like we could do this with any one of our suits, so we'll just take that times 4. And some people write this as 4C1 because it doesn't matter which kind you want. But this is all it is. So we would just do that times 4. And we take that answer times, it's not 5, times 4. And here we get this. I get 1.98 e negative 3. Remember, that means move the decimal 3 places to the left. So we get 0.00198. Okay? Now, for the poker aficionados out there, they're going to say, wait, that's different. Well, understand that this is also including straight flushes and royal flushes and all that. The probability of any kind of a flush is 0.00198. Now, the last one that we're going to look at is pretty tricky. It's the probability of getting 2 pair. Remember, we're dealing with a 5-card hand here. Okay, so this one is super tricky, and I probably wouldn't give a test question like this much, but you never know. Maybe your teacher might, or maybe they'll give it a bonus or something. But let's start out thinking about it this way. If we have 5 cards, then ultimately what's going to happen here? If we want 2 pair, that means that like one of these groupings has to be the same, and another one of these groupings has to be the same, right? Maybe we get like queen, queen, and then ace, ace, and then something else, right? Like maybe a 7 or something. So here's an example where you might have 2 pair, okay? So the first thing that we are going to figure out is the bottom, because that's super easy. We have 52 cards, and we're going to choose 5 of them. All right, I did that part. You guys do the rest. because the rest is a little harder. I don't want to. No, okay, we'll work on it here. So getting two pair. Let's figure out, if and there are other ways to do this, but this is just kind of the way that makes sense to me. So we have two different kinds that we need to make pairs of. And, between, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace, there are 13 kinds. And we're going to choose two of them in order to be a part of our two pair. Okay, so that's the first thing we did. Now, once we choose, maybe say queens, understand that there are four queens to choose from, and we're going to choose two of those. And there's also four aces to choose from, and we're going to choose two of those. Okay. Now, I know that seems kind of strange, but like I said, this is a tricky math problem. So we first had to pick two kinds that were going to be a part of our pair. So 13 kinds total between ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So we had 13 kinds, and we're going to choose two of them to make pairs. Then once we pick our kinds, we have four queens to choose from, and we're going to choose two of them. We have four aces to choose from, and we're going to choose two of those. Now we still have to deal with this last card over here. Okay, so there's other ways that you could do this, like I said, but I'm going to stick with this. So we've already picked two out of our 13 kinds here. Now I have 11 left. I have 11 kinds left over, and I have to choose one of them. I have to pick something that's not a queen and it's not an ace. So I have 11 choices. I could pick a 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, or King. Okay, so I have 11 left over. Then, once I pick that, maybe I pick my sevens, now I have four sevens to choose from, and I'm going to choose one of them. So this is how you would go through and calculate the probability of getting two pair when you're dealt a single 5-card hand. If you do this on the calculator when it's all said and done, I think you come out with 198 over 4165, or in other words, about 0.0475-ish. We'll round it. So a little under 5% of the time you're going to get two pair. Okay. All right. Well, like I said, these last couple questions, these are pretty hard, but they just kind of bring around that idea of some combinations in probabilities. You'd probably want to look at questions like these would be ones that I would probably focus on as far as homework goes. Questions like this or like this. Some of the other ones, earlier ones we did, those last couple questions were pretty tough. But I hope this has been helpful. I hope you learned a little something about how probability can get complicated. There's a lot of different ways to do some probability, and hopefully you learn how to use your calculator. And I hope you're able to figure out some probabilities in life. All right, good luck.